In this video, let's start our adventure learning about rational expressions. We're really just today going to answer what these things are and how we can simplify them. And it's really just simplifying fractions. So what is a rational expression? A rational expression is where you have a ratio of two things. We could call them P and Q, where P is a polynomial and Q is a polynomial. So it's a ratio of two polynomials. And you see you'll see lots of examples here in a moment, but you see one right down here at the bottom right there. That's an example of a trinomial being divided by a binomial. So that's what we mean by a rational expression. Now, the domain of anything, a domain of any function, is what x values can go in a function. What is allowed to be plugged into a function? So, for example, if you're just looking at x squared minus 5x plus 4, anything can go in that, right? And if you're just looking at x minus 1, you could plug anything you want in there. Negative, 3, 0, 1. You know, if you plug 1 in, you get 0. That's no big deal, right? So the domain is what's allowed to be plugged in. And these polynomials, the numerator and the denominator separately, have domain of all real numbers. So now the question is what is the domain of a rational expression? It is everything but the zeros in the denominator. Why the denominator? Well, you can't divide by 0. That's not allowed in math. You're not allowed to divide by 0. Okay, so we're going to avoid having a 0 in any of the denominators. So let's look at this skills pre-check here. What values must be excluded from the domain? Well, this is real simple, folks. All we do, let's zoom in here, we focus on the denominator. We say that can't be 0. X minus 1 can't be 0. So let's solve for what I like to call the problem children. X minus 1 equals 0. So if we add 1 on both sides, we see x equals 1 is what we would call a problem child, an excluded value, a number that we're not allowed to plug into this entire fraction. Can never plug 1 into this. So the domain here would be x is not allowed to be 1. These would be called excluded values. You're not allowed to have x equals 1 because it causes the entire fraction to blow up. It causes the denominator to be 0. All right, moving over here. Simplify this fraction here. Let's see if we can do this. You think we can do this? What do you think we do here? How do we simplify fractions? We usually simplify fractions by canceling. So what you're going to see down below here when we go through the notes is we're going to factor first. I'm reverse foiling. I've got tons of videos on factoring on my channel. So I factored first. Now, is there anything on the top and bottom that match? Any factors that match? Yeah, we got this one and this one. So the answer here is x minus 4 over x plus 3. This is what it means to simplify a rational expression. So let's get down here to more of the notes, and skills number 1, determine if they even are rational expressions. So remember the definition of a rational expression? It has to be a polynomial divided by a polynomial. So is this a polynomial? Yes. Is this a polynomial? Yeah, it's called a binomial. So the answer here is yes. This is a rational expression because it's a polynomial, happens to be a trinomial on the top, divided by a binomial. Let's go over here to letter B. Are these polynomials? Well, the top, no, that's not a polynomial. You're not allowed to have a square root function, within this. So no, that's not a polynomial. So no, this is not what we're going to be working with in this chapter when we're just dealing with rational expressions. All right, moving on down here. So that's skill 1. That's pretty easy, right? Just spotting whether they are or they aren't. All right, determining the values that are excluded. So how do you do this? You find the zeros in the denominator. Only the denominator. I can't repeat that enough, right? Only the denominator is where the problems come from. So this is not allowed to be 0. So in your notes, you might want to write that out. Since x plus 1 can't ever be 0, we solve. X plus 1 is not allowed to be 0. I like to put that not allowed to be. That kind of drives it home, right? Minus 1. X is not allowed to be negative 1. So this is called the excluded value. So we just found a value. It's the number negative 1. That's the excluded value here. We don't even have to turn our attention or look at that numerator at all. It doesn't matter. We only look at the denominator. All right, let's go over here to question D. Question D. Which part of the fraction do we look at? Only the denominator. So this can never be 0. So remember in the last chapter we solved equations like x squared minus 5x plus 6 equals 0. I'm going to say not allowed to be 0. So how did we solve these? We used the quadratic formula, we used square roots, we used completing the square, but there's an easier way that you want to check first is, can this thing factor? And I think I've set this up so that it will factor x minus 3 and x minus 2. So then, remember how we did this? We split it off. X minus 3 is not allowed to be 0. X minus 2 is not allowed to be 0. So x is never allowed to be 3. That's called an excluded value. And x is never allowed to be 2. That's the other excluded value. So here's the 2 excluded values. And we found those by setting the denominator equal to 0. Do you notice that we never needed to worry about that numerator? Okay, so that's skill number 2 in this section. We're pretty easy so far, right? Is it a polynomial or not? And then the excluded values has to do with the domain. So now let's get into simplifying. So do you remember that problem we did at the beginning, the pre-test or pre-check there? How do we do these? We factor everything. So we look for GCF. We reverse FOIL. Okay, we do every possible thing we can, and then cancel factors. You can only cancel factors. You can't cancel terms. So don't forget, like, for example, in A, this x and this x do not cancel because they're not factors. They're simply terms being added. I get that question a lot, so it's probably good that I mentioned that. So let's start by factoring. I see a GCF in the top. So just look at the top. Don't worry about the bottom yet. What are both of those divisible by? 4. What's left behind? In other words, if we did the distributive property, how would we get this question right back? It would have to be x minus 2. And you can always check your work. 4 times x is 4x, and then 4 times negative 2 is negative 8. All right, then go to the bottom. I'll change colors here because it's sort of like a different problem, right? It has a different GCF, and it is 10. So we factor that out. We get x minus 2. Oh, wow. Okay. So now we cancel. So we factored, then we cancel. X minus 2 cancels x minus 2. That leaves 4/10. Now this is a fraction that can reduce, so I will divide the top by 2 and the bottom by 2, just reducing a fraction, easy peasy, right? The answer is 2/5. So all the x's did end up canceling, and we just get the constant 2/5. That doesn't always happen, but it happened in this first question. All right, moving over here. Let's factor the top and bottom. Now, as I look at this, is there anything to do in the bottom? No, it's just x minus 9. So now we have to see it, just maybe, is there an x minus 9 on the top? Well, I see a GCF first. Notice I put this equal sign because I really am rewriting the fraction just differently. So I'm going to factor out a 2 here, and I get x squared minus 9. All right, and then I go ahead and factor the top and bottom. X plus 3, x minus 3, that's greatest common factor, and then reverse foiling, and I have an x minus 9. So is there anything that can cancel? No, there's absolutely nothing. So this is fully canceled. I can't cross anything out. Maybe this is a typo and I meant to put x minus 3 on the bottom, but I didn't. So this is the way we're going to work the problem. There's nothing that we can do there to simplify that problem. All right, so let's go to question C. So this is looking a little more intimidating now, right? These numbers are getting bigger, but that's okay. We always start with the greatest common factor, and we have our fingers crossed that just maybe if we take, for example, a 4 out of the top, it's going to make the top look a lot nicer. X squared minus 4x minus 21. Okay. And then while I'm at it, let me see if I can reverse foil the denominator. X minus 7, x plus 2. Okay, keep going because we have a trinomial in the numerator here. I think I want to split that up. So this is 4 times the quantity, x minus 7, x plus 3, all over x minus 7, x plus 2. I hope this goes without saying, but this is not mental math, folks. You got to show your work. You got to have some scratch paper at the very least when you're doing this, because this is just too much to keep track in your head. I would never do that. I see an x minus 7 on the top and the bottom, and I don't see anything else that can cancel. So I would write my answer in just like this. And by the way, some students always ask me, should I multiply that out again? You can. It's not necessary though. So I'll put an or here. So either of those are really great answers. I think you'll find in this chapter that factored form is more useful. So I just keep it in that form. So it's more useful. Okay, let's look at this next question, D here. All right, so the top does not have a greatest common factor. You see how this is an even number, 2, 5, 3. They're all prime numbers, and they're not even, of course, if they're prime. So really, I got to just hope that just maybe it's 2x and x. That's the only way to make 2x squared. And if I put a 3 here, I get my 6 on the outside, and 6 minus 1 can make 5. But I really need the 6 to be negative, and that to be the last to be positive. So, well, actually that doesn't work, does it? Because this is positive 3 here. So we got to go back to the drawing board, folks. So let's see, is there another way to do this? Or is this a typo as well? Is this paper just filled with typos here today? So 2x, so 6. So that would be minus 3. Minus 3 plus 1 is, I think, the only way we're ever going to get a 5. So for purposes of doing this problem, let's leave it like this, I guess. So the bottom would factor into 2x minus 3 and 2x plus 3. Okay. And does anything cancel? No, unfortunately it does not. Again, I think maybe I tried to do some mental math there on that numerator, and I ended up messing it up when I created these notes. That's what I get for doing that, right? All right, so nothing cancels here. So this thing is fully simplified. All right, we've got a few more questions here that we can practice. What values must be excluded? It says, what values must be excluded from this guy right here? What would it be? What do we need to leave out? Well, this denominator can never be 0. Can never be 0. So x is never allowed to be positive 3, because that would cause a 0. And x is never allowed to be negative 1. Never allowed to be negative 1. And let's simplify this question here. So this would be, hopefully these will factor, right? Hopefully I didn't mess these up. So we've got x plus 3, x minus 2 is how the top factors. The bottom factors into x plus 5 and x minus 2. So I do see a couple factors, binomial factors, those are called binomial. They're two terms, factors, and they do cancel, leaving x plus 3 over x plus 5. X plus 3 over x plus 5. So let's do our little I can statement. Can I identify a rational expression? Yeah, it's got to be polynomial divided by polynomial. Can I determine which values for a rational expression makes it undefined? Sure. You just look at the denominator and find the zeros there. And can I simplify these things by factoring? Yeah, you just factor and cancel like crazy. And sometimes it's 3, 4, 5 steps, and then at the end, maybe you have to reduce. So it just is the way it is. All right, so this is the introduction to rational expressions. Hopefully this gives you a good foundation to then build on the next few sections. All right, until next time.